We're starting chapter 12, and section 12.1 is linear and non-linear functions. So we're going to talk about the difference between those two. In the last chapter, we talked about linear functions. In this chapter, we're going to spend a lot of time talking about non-linear functions and polynomials. So that's what we're going to get into. And the first thing it talks about is rocket launch, and you just saw one of those. So if, let's say we plotted those numbers and we got something like this right here, and if we look at this as it's going up, you know, that rocket takes off pretty fast and goes up and then kind of slows down, and then parachute comes out and it comes down. So if we're looking at it going up from, here's the seconds, is it going up at the same height every second? So from here to here, is that the same as from here to here? And if you look at the first one, you can see a difference of 38, and you know, by the time we get to the bottom one, you can see there's only a difference of 4. You know, this one here has a difference of 10. So obviously not the same every second. On the other hand, if we take a look at it as it's coming down in the parachute, you can see that every second it's going down by another 10 meters. And so going down, it would be the same. So this one here would be linear. This one, on the other hand, would be nonlinear. It would be some type of a curve to that graph when you got done. It would not be a straight line. That's what they mean by it's not linear. It's no longer a straight line. Linear would be a straight line one as we went through it. Okay. Let's get rid of that sidebar here. So we're going to talk about nonlinear functions, ones that do not have a straight line. So here's an example of a nonlinear function. You can see we've got a curve to this thing, you know, it kind of goes like that. Or we've got this one over here. We've got those. Those are examples of nonlinear functions. They are not curves, or they're not straight lines. They are curves, and so that makes them nonlinear. So both of these examples are nonlinear functions. Now they still can be functions, but they're nonlinear. They're not straight lines as we go through that. Okay. So what we want to figure out is whether things are linear and nonlinear. Remember, in the last chapter we talked about this formula, the slope-intercept formula, where we have it in the formula y equals mx plus b. If we have that, this is linear. This gives us a straight line. But notice that we have to have it in some kind of form where we've got y on the one side, on the left, we've got some fraction in front of x, and then we've got a number here. And you know, that number could be 0, but most likely is not. That is an example of linear functions. And so let's take a look at this and see if we can determine from these equations whether these are linear. So is this in the formula y equals mx plus b? And y, m would be 1 in this case, and b would be 4. So yeah, that is, and so therefore it is a linear function. How about this one over here? Can we get this one into this form, y equals mx plus b? Remember that, you know, I mean, they might move it around a little bit. Is there any way that I could move this to get that up there and have a plus sign? And now, if you look at it, the only thing I could do, I could get rid of the x on this side. I could cancel it out, you know, by going x over 1, but that's just going to move it to the other side. I'm still not getting where I want to go. I cannot, in this one, find any way to get it into that kind of a formula. So therefore, this is some type of nonlinear function. This would give me a curve if I graph it. That's what they're trying to tell you when it's nonlinear. Get rid of that. All right, what if we just had a chart? Let's take a look at this chart. And let's assume that here's my x, here's my y. So x is going from 2 to 4 to 6 to 8, always up by 2 every single time. Same thing. If they both are going up, they don't have to go up the same amount, or up or down, but they have to be consistent between, all the x values have to vary by the same amount, all the y values have to vary by the same amount. So for instance, over here, This one went down by 15, down by 15, down by 15. As long as these are all the same and then these are all the same, then this is linear. So this would be an example of a linear function. Now let's take a look at this one over here. As I go from, on x, go from 1 to 4, that's 3, 3, 3. Each time I'm going up 3. My y's, I went up 15 the first one, from 1 to 16. Then I jump up 33, and then even more, 51. So these values here are not the same. Therefore, I don't know if that's a good letter to use there. Therefore, that is nonlinear. They have to be the same. They have to be arithmetic progressions, basically. I mean, we have to have that arithmetic increase on each one in order for it to be a linear function. All right, here's another example. Use the table to determine whether the number of teams is a linear function of the number of rounds of play. So we're talking about a tournament. If there's only one round left, there are 2 teams left. But if there's 2 rounds of tournament play left, then you have 4. So my difference would be 2. Here, another one. My difference now is 4. Difference here is 8. Difference here is 16. So you can see that this is not going up by the same amount every time. So therefore, non-linear over here. All right, so this is your turn. Do these. Make sure you do C here. That's the chart. So stop the video and do those 3 in your notes. Determine whether they are linear or non-linear functions. All right, so the first one, we've got y equals 2x cubed. Is that, remember we're trying to get mx plus b. So we've got the 2, that could be m, but can we get x by itself? We've got an x to the 3rd power, x cubed. There's no way for me to get that without changing the y, reduced down. So when you see something with a power in it, then that's not going to be a linear. So this is going to be whoops, that's not right. Non-linear. All right, how about this one? This one might be a little bit tricky. Remember, we're trying to get it in the form y equals mx plus b. We've got y, we've got m. The m would be 3, mx. We don't have b, or do we? This would be 0. So that would be okay. Even though it's a 0 value, it's still a number. It's not, it's still, we've got the right setup. So this would be linear. It would just happen to go through the point 0, 0 is what it would do. And our next one, if we look at this, here we go up 5,